Let's see. Okay. Let me grab the link here. I'm trying to just make sure that so there's the link and there's the link and sweet. Oh, okay. All right, well, it's 11:01 on, let's see, is today the 21st of December? Yep. 11:01 Pacific Standard Time on the 21st of December, 2016. And I have no idea how many, what number Hangout this is. But I've been doing them consistently for a couple of years now. And I have to say that my sense is that, you know, persistence and just showing up is 9/10 of the work. So, we have a lot of exciting things to talk about. I think there was on Monday, and I'm sorry I haven't posted Monday's meeting yet, but we had a good informational, and I think a lot of people got more educated about all the issues that go into the coin conversion and why we're sort of contemplating the sets of options that we're contemplating.
Right, that needs to be posted because a lot of people are asking for it.
Yep,
it was an awesome session. It was just wonderful.
Good. I'll make sure that's posted today. Absolutely. I need to work with Christian to get it into the YouTube channel. And Christian, I continue to be in your debt for helping with all the AV. It's really a huge help that you do this, and the community is in your debt as well. So thank you for this service, and looking forward to getting you compensated at ASAP. So let's talk a little bit about. So some people have been communicating with me about a refund structure, and in order to sort of tie up loose ends. I don't know how that would work practically. So I'm still working with some investors who want to see some kind of refund as a part of the coin conversion event, and I don't honestly know how that would work. So trying to look through what their actual concerns are, what they really want, and see if there are ways to help them with that. But I also want to say that the coin conversion process is practice for doing the same thing for the other major coins that are going to be native on the RChain platform. So the R coin will have a kind of privileged position for some number of months on the RChain platform. But then after that, we want to offer a conversion for Bitcoin and for Ether, so that to provide a kind of tethering mechanism between the RChain coin and the other major coins. So initially, we'll just be talking about Bitcoin and Ether. And I think that as we've discussed many times before, what that does is it dramatically extends the reach of the platform. And then if you have contracts that only accept RCoin, then what that does is it also dramatically increases the value of RCoin. So in particular, what we're talking about is the attention economy contracts will be written in such a way as to largely just be about RCoin. So RCoin is utilized not only to run the virtual machine, but also utilized exclusively to run the attention economy contracts until someone, clones those contracts. But we should have a sufficient head start on that as well to make it dramatically improving the reach and value of our coin. So essentially, we get to capitalize on the coin distribution of Bitcoin and Ether, which I think is a significant win. So.
Oh, absolutely. I think this is brilliant from a market adoption strategy.
Cool.
To also offer redemption paths for Ethereum and Bitcoin.
Right. So what that does, though, is that says that the conversion methodology that we're going for AMPS is really just part of something that we're going to be doing more than once, right? So it's this process is the first step in a much bigger process and we want to iron this out in the case of AMPS. So it has value to the community no matter what. And just shaking out all of the gotchas here are actually really, really important. It's a part of getting our hands dirty and making this all work. So that's one update. Let's see. Before the first conversion event from AMP, there should be more info about the lead monopoly of our coin. How many months? When does that period end? Yes. So I agree that. So what we're talking about is a 6 months period from the point at which we have roughly the equivalent of homestead level functionality on RChain. So if you think of the very first Ethereum release, so we want a release like that together with a number of nodes operational. And so I'm going to put a number out there and say 10 operational nodes. So 10 independent autonomous operational nodes together with a feature set. And that leads to the next point, which is that I want to then have a natural notion of soft fork that happens at a kind of a rhythm in the same way that we think about releases of other software packages, like releases of the JVM or releases of the CLR. So there's a soft fork, which and the adoption event in which nodes switch over to the soft fork to get the new features marks a kind of a community level acceptance criteria. So we roll out a new feature. There's a fork, a soft fork, in the sense that it doesn't perturb clients too much. So in that particular case, what we're saying is that adoption by the community, the move over to the soft fork, represents a kind of acceptance criteria. And so I want to put that into the milestones document that we're talking about, so that we have as many of these observable events as possible, so to measure the progress of RChain relative to community adoption and uptake. So hopefully that makes sense. Is that, Ed, do you follow?
Yeah, I do. And yeah, hopefully we can also align those to the investor milestones, because any large investors, will not sort of plunk down $10 million in cash or whatever to say, here it is, have fun. It's going to be, in investment tranches. So we would link some of those milestones to the investor tranches as well.
Yeah, exactly. Now, T asked, but can AMP applications really get ahead during Homestead if the network isn't even ready to get real users of the applications? So again, I think that getting ahead is largely to do with the contracts that are coin only. So after the conversion event, amps are a thing of the past. They're in the rear. They're way distant in the rearview mirror. So I don't even want to talk about those anymore. So can RCoin holders have a significant lead? And my argument is that the real lead here is not the utility of running the virtual machine itself. The real lead is the ecosystem of contracts that are RCoin only. And the RCoin Cooperative and the RCoin Incubator are going to be miles ahead in releasing contracts for profitable applications or infrastructure applications that make the RCoin, sort of give it a leg up, so to speak, while at the same time leveraging the distribution network of the other coins. So again, think about this. Think about it in terms of social applications. So let's say a dApp developer creates an exciting new dApp. Let's say they create an exciting new music creation app. And I have examples of the kinds of applications I'm talking about. So let's say that they've done that, but now in order for that app to be really valuable, it has to become social. People have to know about it. Let's say the app allows someone to write little pieces of music and then connect those pieces of music to other pieces of music that other people on the application have written, and in this way, through social interaction, you're able to create more and more interesting and exciting music, right? So the primary application is just this new experience for the creation of music. Right. In order for that application to succeed, it has to be social. In order to be social, it needs the attention economy to promote it and to get it in the hands of other users and get those users coordinated. Right. So the contracts that sort of automatically make that music app social are the attention economy contracts. Those contracts will be RCoin only. So if you write an app, even if the app uses Ether or new Ether in this case, to run on the virtual machine, in order to become a social app, it still has to use RCoin. And now, so every dApp that has any other coin automatically gets linked to RCoin, thereby dramatically increasing the reach and value of RCoin. So the lead here is not the lead on execution on the virtual machine. The real lead is on the attention economy service level contracts, and there that's why I think it's of significant business value to get the other coins in sooner rather than later. But for investors who are more cautious, we will give them a good lead time, and we're defining those events that describe the lead time.
Yeah, I agree completely. If in addition to the contract and use of the contracts and attention economy that would be based on RCoin or whatever they're to be called, then it's not. In addition, it's the social network that evolves around that usage, and that's what becomes more and more sticky over time.
Exactly, that's exactly right, and that's the way it should be, right? Because social is the glue. And that's what we've been observing all over and over again. Social is the glue, and the social is a part of what accelerates the network effects. So now, RChain has always, from the very beginning, said that the attention economy contracts are the means by which we measure to see whether or not RChain is delivering. So if we go back to the RChain architecture documents and the budget proposals that we evaluated 2 or 3 weeks ago, right? Rolang, which is the contracting language that is a part of RChain, that contracting language is a general purpose programming language. Now, because it's a general purpose programming language, you have to stage and phase the different kinds of applications it's good at first. And so what we want, so rather than have it first out of the box be good at scientific processing, which might be reasonable if we have, climate change as one of our targets, but rather than have it be good at scientific processing or graphics processing or anything else, it's going to be good at contracts, blockchain contracts. And in particular, the kinds of blockchain contracts it's going to be good at are contracts that are related to content delivery and content promotion, i.e. the attention economy. So yes, from the very beginning, those are the suite of programs that will be utilized to evaluate whether or not RChain is actually delivering. So hopefully that answers the question from 1T to everyone. Okay, so moving right along, there are some other really, really exciting things that are happening. One is I've already started having very, very skilled and sophisticated programmers come to me and say they want to donate their time to help with the implementation. So to me, this is bigger than, in many ways, this is bigger even than multi-million-dollar investments. When you have sophisticated, skilled programmers saying, hey, I've read your docs, I've heard you talk, and I see that this is a giant opportunity and it's technically reasonable and technically viable. I want to get in on this, and I don't even need to be compensated. I just want to work on this. That's even bigger than a multi-million-dollar investment, because it's the kind of validation that we need in order to have this be a network of the people and for the people. Actually, I had a really nice conversation with a developer, Matthew DiFerrante, who said that he came to this through the paper that I wrote, Linear Types Can Change the Blockchain. And he was so excited by that paper that he did a little prototype of the concepts in that paper and had a number of questions. And a lot of those questions are being addressed directly in the RChain effort, both in terms of the architecture document and in terms of the implementation. So this is very, very exciting. This is the kind of network effect that we need, and it's the network effect that we want, right? First we make contact with developers, and as more and more developers come on board, because they see that it's the right thing to do, not because they're motivated by a quick buck, then we're going to be able to release more and more features. This is how I've wanted this project to go from the beginning. I'm not saying that I'm opposed to people making money. I'm not saying that this platform won't make oodles of money. But what I am saying is that the primary motivation has to be that it makes sense, that this is the right thing to do. And then we build it, and then the money will find its way to the right places. That's the way these things really work, in my opinion. So let's talk a little bit about, just very briefly, we'll talk a little bit about how these developers and I are beginning to coordinate on the next phase of work. These slides were crafted on the fly this morning in pair session conversations with Matthew, and I'm hoping to have similar conversations with David. So essentially, what we're doing, and I mentioned some of this on the Casper stand-up on Monday. Essentially, what we're doing is we're creating a reactive API that is uniform for the chain store, i.e., the local store where we store blocks, and inside the blocks we store diffs of VM bytecode, right? So this is essentially the transitions of the machine, right? So we have a reactive API to the local store and a reactive API to a stream, i.e., some other node on the network with which this node can be syncing to come up to speed on the replicated state. What would be the local storage? An example of such would be a reactive MongoDB. Another example, an example of the reactive API for the local stream would be a reactive API against an AMQP provider. there are extant open source projects that satisfy this and can be utilized to realize this capability relatively quickly. So we were talking with Matthew and David Curran about whether or not they want to dig in on this piece. Another piece of the puzzle that's important is how to get from the row VM to the VM bytecode that's going to sit on top of the blockchain. So we've identified the compilation path from the row VM onto the Rosette VM, which essentially is described in this paper here. 1 second, I'll get you the paper. Hang on. Here it is, right here. So let me grab and then paste it into the chat. Okay, so the compilation path is described here. And so this arrow here, it doglegs. So you translate this into a tuple space. So you have to have the VM plus a tuple space implementation, and then and that tuple space you can utilize a distributed hash table. So that's what's necessary to get from here to here, right? And then the question is, what's the implementation of the VM that runs that bytecode? Today we have a C++ implementation. What we want to do is to get to an implementation that's Scala plus, that's a clean room Scala implementation, right? So notice that at the level of what we're storing with respect to the blockchain, that's just VM stuff. It has nothing to do with the execution of the bytecodes, right? So presumably a C++ implementation, like the one we have right now, can read off blocks and run the C++ VM, but that's not where we want to be. Where we want to be is that a Scala implementation reads the bytecodes and then executes them. But the nice thing about this approach is that these two groups can be working in parallel, right? The group that's working on this does not have to be worried about the progress of this group, at least initially, or actually for some period of time. And this is the way I run all of my projects: is to find decompositions. It was just like, it's, you know, like I'm a cook, and you know I've worked in relatively well-reviewed restaurants in New York, and you know it's all about timing. It's all about, you know, figuring out how to run things in parallel and when to put, you know, longer cooking things you know, on the flame versus when to put shorter cooking things on the flame, right? And that's effectively what we're doing here. As an example of the way to accelerate the technical progress, one of the things that we want is that the bytecode be able to be serialized and deserialized. And we want that serialization and deserialization to be available to multiple different kinds of implementations. So what we will do is to create a BNFC spec from the existing Rosette implementation. So each bytecode will be part of a, I'm sorry. So each bytecode will be spec'd out in a BNFC specification. I can show you examples of what such a specification looks like. And that will auto-generate from the spec serialization and deserialization for the bytecodes for all the major languages. JVM, which gives us Scala, Clojure, JRuby, etc. It will also give us serialization and deserialization bindings for OCaml, for Haskell, C, C++. So by the judicious choice of BNFC to do the spec of the sort of the high level re-engineering of these bytecodes, we get much greater surface area. We also auto-generate all of the documentation. and a number of other things. Now, what that doesn't do is that doesn't produce the VM that processes the bytecodes, but it makes it possible to have implementations of that same VM in lots of different languages. For us, the first such re-implementation of the existing implementation will be in Scala. Okay, so hopefully that describes that. And then how this all fits together is a node with local store and the ability to stream with other nodes, together with the replication semantics, i.e. the consensus. This is what is normally will be thought of as a node. So one of these nodes needs to be able to talk with all the other nodes, right? And this effectively constitutes what we want to call the homestead release. And we're marching to that rather rapidly, and we hope to be able to provide at least this functionality in just a very short period of time, so people can start to engage with the bytes and see our design decisions, our technology choices, and give us feedback on whether or not that the choices that we're making make sense. So that's a quick update on kind of the technical progress, and let me stop there and see if people have any questions. Oh yes, thank you, Ed. It also provides an in-memory representation for each of the language bindings. Yeah, I'm sure this is kind of boring for a lot of people, but for me, this is what makes me excited.
No, definitely not boring. I was curious if you would, and I know you just stopped screen sharing, but if you could further differentiate between the two diagrams. You mentioned that they were different, but
yeah, sure. Hang on. Let me go back to screen share. Okay, two diagrams. So this diagram is all about the structure of the blocks, not about the content of the blocks.
Yes.
It's all about how to get blocks from storage into memory, from memory into storage, or from a stream into memory, or from memory back to the stream. Right, so that's what this capability is about. It's effectively about I/O over block structure.
Oh, it's like, okay, I see. It's like querying. Gotcha.
Well, it's reading and writing.
Yeah.
Yeah, and so I'm glad you brought this up, because one of the things that's really important is that this is actual, honest to God, decent Scala syntax.
Yeah.
But the aim is to self-host. So once we have row VM and the whole, once we have RChain, then we want to rewrite RChain in RChain and kick away the JVM implementation. All right, so that's going to be so we will bootstrap, and so this whole idea of having the reactive API for the storage and the reactive API for the for syncing with other clients is critical, because that's if you look at this syntax is also more or less the syntax in Rolang. So so we're preparing for that day in which we can port the JVM or Scala implementation over directly onto Rolang itself. All right, so this is that's sort of why I put this little annotation here, because that's the this is the abstraction that is central to the Rolang contracting language, and why we want to be able to structure the Scala implementation in this way.
It would also be. It also kind of looks like a prototype for what Ethereum would call warping a node, and like downloading the history of or recent history of blocks up to a certain point of economic verifiability.
Yeah, exactly. That's exactly right. So all we're doing is using the extant stuff that's come from big data, right? So big data has successfully been employing the reactive model for quite some time.
Yeah.
So this is why I was going on and on in the mid 2000 from 2000 to 2008 or 9, going on and on about monadic APIs for the web. Right, it's really important that you understand this design pattern, because that's how we're going to handle things at scale. And this is the thing that composes. This is the thing that has the clean semantics, and this is the thing that industry is utilizing. Whether you're talking Apache Spark, or the RX framework from Microsoft, or Link from Microsoft, or what's the Scala framework? Quill, or any of these other major frameworks, right? The reactive design pattern is how you want to structure massive I/O, and we want this to be able to be, scalable massive I/O, right? And guess what? That scale, the reactive structure maps directly onto the core constructs of the Erlang contracting language, and that's not by accident. That's by design. Now, the difference between this diagram versus this diagram, this has to do not with the I/O to the block structure, but with what's being stored in the contents of the blocks. So essentially, what's being stored in the contents of the blocks are.
Okay. I see. Gotcha.
Yeah. So what we're talking about is what's going to be in the blocks are diffs on bytecodes, right? It's transitions of the virtual machine.
Mm-hmm.
That's the way to think about it. So we have to have an implementation of the virtual machine that reads bytecodes or transitions and then runs them. Okay, so that's what this is about, right? And those two efforts can be done independently, right? This part is generic, right? Yep. It works for any block structure for any kinds of content, right? You could just take the existing EVM and rewrite it in the reactive style, and it would be better factored code. End of story. And that would be code that was more in alignment with the way the rest of the industry is going for high throughput I/O. But we're just making that choice because the abstraction fits with the abstraction that we've been promoting for quite some time. Now, with respect to the VM design itself, again, we're making very specific decisions that have to do with research that was conducted from the late 80s on through the early 2000s and deployed and tested in industry, right? So the VM design that we're looking at, or that we've chosen, has an explicit representation of concurrency, of fine-grained concurrency. So there's a notion of concurrent execution that is distinct from the JVM's notion of threads. And that's represented in the Rosette VM, and anyone can go and launch the Rosette VM right now. You can go to our repos, build it, and run it on Mac OS or other flavors of Unix to get a feel for what this looks like. And the question is how to go from the existing C++ implementation, which goes back almost 20 years now, to a more modern implementation, and I've described the implementation path for doing that, and how to do that in such a way that we get the most reach and the most possible bindings to the greatest number of implementation platforms. Our chosen one is Scala. Scala 1 makes it possible for someone to do it in Java or Clojure or JRuby. But because of the way we've chosen to represent the bytecodes, it would be quite straightforward to produce also an OCaml implementation of the same VM, or quite straightforward to produce a Haskell implementation of the same VM, and not starting from scratch, but starting from a representation of the bytecodes that makes it much, much easier and guarantees a much, much higher degree of interoperability amongst all of the different implementations. So that's the difference between these two diagrams. And then finally, the third diagram is how we tie it all together, right? So a particular node needs to be able to check its local store and talk to other nodes, right? And what is it doing? Well, it's checking its local store for blocks, what's in those blocks, bytecode for the VM. And then nodes that are operating over the same namespace or over related namespaces where you have causal interoperability, like A is calling from, a contract is calling from namespace A to namespace B, that contract, so those VMs have to have consistent state. And that consistent state is guaranteed by the Casper semantics, right? So local store, plus streaming, plus the bytecodes, plus Casper is what constitutes a essentially, our first milestone, right? Really, I wanted to not have all of Casper in the first milestone, but in terms of the first level of usability of the network, this is a reasonable chunk from the point of view of application developers wanting to be able to develop on the network. So this would constitute a Homestead style release.
That's so cool. It resembles Special K, but with replication semantics.
That's exactly right. And I'm also glad that you said that, because the whole point here is that there's a bit of a chicken and egg. When I sit down and I look at what I would really like in order to do this, I'd really like to just take Special K. Like if Special K didn't have the technical debt that was associated with using older Scala libraries, right? If that problem had been solved in some other way, then I would implement this part on top of Special K and get the reactive API for the storage and the reactive API for the streaming for free.
Yeah.
Right. That would have just come for free. But what we're going to do is we implement this at a lower level, and then we build Special K on top of this structure. Right. And at the same, so Special K will sit up here and have access to the VM, and thereby get the delimited continuations and all the other nifty doodads. So Special K will sit up here and provide the content delivery mechanism, but in a setting in which you also have the economics.
Yeah. All
right. So that's.
Can it be written in Scala or in Rolang?
It'll be written in Rolang.
Okay.
So that's the other sort of strong, solid reason why we want to do this kind of refactoring, because once we realized that we wanted the content delivery mechanism to have all the metering and monitoring, then the argument that it should be written in the contracting language becomes dominant at that point. So that's why RChain is refactored in the way it's refactored.
Are there Pascal terms in the new Special K, or is it
Prolog terms? You mean?
Prolog? I'm sorry. What am I saying?
Jim, if you want Pascal terms, it's all you're free to do that. So yes, I mean essentially the whole point. Let's see if I can try to I'll just sketch for a second, okay? So that people can kind of understand what's really going on. Let's begin with something that everybody is familiar with, and that is the URL. Okay, let me go to Menlo. So in a URL, we have the scheme : whack whack. Stop that. And then we have the path. Okay. And then finally we have the query string. All right. So you can think about URLs as providing a address for a resource. So one of these things, so a URL effectively turns the internet into a giant key value database, right? So this thing, if you're talking to a bunch of web servers, that thing can be resolved to a resource. Try it like that. Okay. Now, and if you could put as well as get, then this thing becomes a channel. All right? It's not just an addressing mechanism, it's a channel. When you have the semantics to put the resource at this location as well as retrieve the resource from this location, then this thing can be thought of as a channel. Now, and therefore you have the right to consider this as something that you can utilize in a PyCalculus process. Right? So I'm allowed to think of URIs or URLs as channels in PyCalculus processes. And that's a very natural thing to want to do. But now there are really two parts to this, right? And one, actually in the case of the URIs, there are three parts to this, right? You have the scheme, the path, and the query string. And the query string was sort of shoehorned in after the fact. But there's a natural way to put all this together into one uniform idea. So let's say that this was, I'm just going to reduce this down to S, and I'm going to reduce this down to A, B, C. And here, I'm going to reduce this down to S and reduce this down to A, B, D. Now, notice what happens if I try to compose these, right? I can't uniformly represent the composition of these two things as a URI, right? Without increasing the expressiveness of URIs. I'd have to step outside of URIs. However, if I turn this into a stream, I'm sorry, a tree, not a path, then I could easily represent the composition of these two paths as a tree, right? So the course, if I interpret this path, so every path can clearly be interpreted as a tree. And if I interpret each path as a tree, then I can get a new tree when I compose these two this way. So I have an ABC and an ABD, and then I get an ABC, which is an AB, which is the common prefix, and then two branches, which are the C and the D. And that's a very natural, clear idea that arises from wanting to be able to compose paths. And by the way, that's what we see in specifications like XPath, right? You want to be able to compose paths, and you want to be able to represent multiple sets of paths. And that's not only for addressing, for querying, but it turns out it also works on the write path. It's not just on the read path, but on the write path. If you wanted to be able to update multiple resources at the same time, you'd want to put these things in all these places in this giant key value database that is the internet. So that's okay. So let me then notice that the next step is I can turn this part of the expression syntactically into A, B, and then C, comma D. Right, and there's no difference here, right? I mean, syntactically, all I've done is to go from this kind of path-like representation to a parenthetical representation, but it's exactly the same information. So this is where the prologue term stuff comes from. The desire to have a compositional model for both addressing and querying resources in a network. And then this piece here becomes the channel of the PyCalculus.
And since those are input guarded, and that's the equivalent to, say, a protocol identifier,
right?
Which is the left side of, yeah.
Exactly. So now, if I just put a continuation on the end of this, right? That's sort of standard PyCalculus syntax. And now, if we flip it round to use the reactive style or the monadic syntax, then what we're saying is this comes out of S, where S is the channel, right? And here's our for pattern supplied by S, and we can now do one better. We can say if some condition. So we're not looking at all resources, but only those resources that match certain conditions, right? Then we run P, right? And so now what we've just done is a step-by-step walk from the most exercised, most commonly understood and heavily used notion of addressing resources through a few design desiderata down to the programming model in Rolang. Right? In step-by-step fashion. And now the final, to make your point, Joseph, the other side of this is that's the read side. Here's the write side. There. Okay, so now not only do we give coverage, we've identified all of the different use cases with a tiny little core syntax. And now, I know this is a long preamble, but to get this back to Jim's question, so you can think of this piece of the puzzle, the scheme part of this, as the scheme part of URI, as effectively a more, this is the fat channel. So what you can prove, if you look at the PyCalculus carefully, you can prove that ports, channels, names, whatever you want to call them, they are effectively unbounded queues. So you can think of those as, and if you give them transactional semantics, the channel is relatively heavyweight to instantiate and it's relatively fat. And so you then want to decompose that channel into lots of little lightweight subchannels. And that's what these things are. So these little patterns here are ways to subdivide the fat channel into lots of little light channels. And you can think of this in terms of pub sub, right? So this is topic, this is subtopic, this is subtopic, etc. So it maps directly onto pub sub semantics as well. So we now have exactly one programming model that covers all of the major programming models that are out there and has a clear, direct, straightforward path from the most commonly used resource addressing mechanism on the internet. So it looks like we've got a bunch of chats. Let me stop there. And
the thing that screws me up a little bit is that with the get and put here on the top, we're talking about a mutable resource, and we're talking about channels.
Okay, so again, what we're saying is this is a key. This is the value. The key part is immutable. What the key points to is mutable, right? If I have a put semantics as well as a get semantics, I can put things at the resource ID, in which case this link can be changed to point to another resource. And therein lies your mutability. So this part is immutable. That's just the path. Now where it gets more interesting is if you have variables here, and then those variables are bound to potentially immutable paths, or in the most general case, when you have variables in here and they're also bound to variables in other in other IO expressions. And what that gives you, and the reason to do that is because it allows you to have broadcast semantics within a single programming model. So in particular, if I take one of these kinds of expressions, sorry, I screwed up. I should have had a value here. Right, so put on this pattern, this value, right? Read from this pattern supply whatever value comes out. So this would really be something like something like that. But for simplicity, I'll do it like this. And you can see code examples of this from Special K. And so you can think of Special K as like the first place where we work this out in detail. Now, in the case where you have variables here, something like this, what you're saying is put this value at all the locations where you have an A, B, and anything, and a D. Right, and so this gives you broadcast semantics. You can update multiple locations all at once in a syntax that's also point to point. Here's your point, and here are sub points within that point. And then when you add variables, you are able to update multiple points under this sub point. And then finally, to make it all really super general, and give us the full picture, right? We get to do this not just for a single source or a single pattern. So now I'm going to generalize it. So this is some arbitrary pattern, pattern 1, source 1, ... semicolon, pattern in from source in, if cond, and now you have the generalized shape, which gives you fork join semantics across multiple channels. So you can think of these as multiple streams that are, and the semantics can be given a transactional interpretation. Only when I get things that match these patterns from these sources that satisfy this condition will I run this program. So you can see this as the transactional boundary, and the state change that is observed by P is that these data sources have been pulled off of these streams just in the case that they match this condition. Otherwise, P will never run. So this gives you a clear syntactic transactional notion, and it nests. P can be one of these things again. So you get a nested transactional semantics that fits directly on top of all of the major internet-style programming models in a step-by-step fashion.
That's really awesome.
That's so cool.
A simple way that you can relate this to diffs in the RChain machine?
Yes, of course, right? Because these expressions are, in fact, what you execute in the RChain machine. This is an expression that compiles to bytecode that you then store in the RChain machine. So what you're going to be storing in these blocks are little bits of bytecode. Where do those bytecode come from? They come from expressions like this.
I guess
So to make it even more clear, so if you go back to this document here, what you have to have above the Rosette VM is a runtime that essentially provides this code right here. It's 2 pages of code, and it talks about how to do the tuple space semantics. Once you have the tuple space semantics, here's the compiler, right? So for each of these expressions, they turn into this Scala code utilizing a tuple space. And then that tuple space can be further refactored using the Scala code into monadic style, so that all of the expressions that we had in the sort of the source language turn into Scala expressions that are monadically structured. And then finally, this monadic semantics and syntax here is back-fed into the source language so that you would get the for comprehension as a part of the source language. So then to produce the bytecode, you just thread this back through. So you start from source here, you run this, you get that, you get this code, and then from there, you backtrack through this runtime semantics here, and then from there, so that effectively gets you into a Rosette source code structure, and then from there you just simply run the Rosette compiler to produce the bytecode.
My question is about the monadic state change.
Okay, so what is your question about the monadic state change?
That occurs, okay. the differences that generates in the tree are what should be communicated, right? I mean,
so what's communicated are the transition. So how do I explain this? Let's take a really, really simple example, right? So what you really, So what you really have is something like this running in its own thread together with something like this running in its own thread. Okay, and those two threads can be separated on the internet. They don't have to be, you know, in the same VM. The way they link up is by this channel and this pattern. Okay, and the rest of the network. So this network here is all about the providing the addressing linking mechanism that links this to this. So this thing here will be running on a VM over here, and this thing here could be running on a VM over here, and then the linkage has to do with the S, which is that particular channel, and the pattern. Okay.
Awesome. Thanks.
Does that make sense?
Absolutely.
Right. And so what's then stored is the choice. So remember that you might have competition. So you might have another one of these, which is doing, say, a V prime, and then you might have yet another one, which is doing, say, a V double prime. Okay. And so now what you have to replicate, so one of these is going to be the winner. You don't know which one, but one of them is the winner, right? So this is, hey, I want to make a request. I'm making a request for a particular airplane seat. And this one is, I'm making a request for a particular airplane seat. And this one is, I'm making a particular request for an airplane seat. And this is the airline reservation. This is the core of the airline reservation, which is accepting exactly one reservation for that seat, right? And then it's going to go and do all the rest of the booking stuff, right? So one of these wins, and that win has to be communicated out via Casper so that everyone agrees on which one wins, right? And that's the actual diffs that's being stored here in the bytecode. It's which of those is the actual transaction. The transaction is the COM rule. So in particular, what we'll get is that, you know, there's a binding of, say, the V prime here inside P. And that is the COM rule or the transaction that is stored in here.
So what mechanisms are in place because a COM rule is essentially a reduction, which is born out of the substitution model, but there could be, even within a single atomic contract, just tons of substitutions that occur.
Yeah,
so
it's not. No, remember, it's not the substitution. The COM rule is a the substitution happens after the synchronization. So the first thing is the link up, the synchronization. So this part of it links up with this part of it. And once you have the link up, then you generate the substitution, which will bind V prime to something inside P.
Oh, that's right. All right. So co-channel pair, and then what's being sent and received. So it's identified just because it's what's being sent and what's being received.
Exactly. That's exactly right.
Yeah.
Right.
Okay.
So that gives all of the, so that sort of walks us through the technical pieces. Yeah, exactly. There are so many. So update on the redemption process and RChain co-op formation. So I spoke with Chris Padova at the end of last week. He's done some review for us. I need to sync up with him today or sometime this week and then we should be able to get the filing going. We have a candidate for the lawyer who will do the final filing. We spoke with him earlier this week. so that the RChain co-op can be filed. The RChain incorporation can be filed. We have drafts of the bylaws, and like the most important thing is just making sure that there's we can amend these clauses, and that's what we're nailing down now. We did give an update on all the other redemption process pieces at the top of the hour, so please go back and look at the recording for that. There are some final discussions about refund stuff that I'm going to need to have with a group of informed investors who are still interested in that. And we have to kind of go through what their actual intent is and how we can accomplish the intent. Let's see. Is there anything else we want to talk about? It's 12:01. Are there potential ICO and timing of that? I don't know. Too many things to think about.
I'd save that easy question for last.
Yeah, right. I mean, so again, the point of making a coin offering or a token offering is if we need to be capitalized through some other means. But right now, like even the redemption process is not about capitalizing the project, right? The redemption process is just making sure that we hold each other accountable for doing what we said we wanted to do. What the RChain community said, as clear as could be, is we want RChain. And so now we're making it possible for those people who put their hard-earned cash towards the scenario second coin offering, make it possible that this gets manifested and realized within the RChain project. That's all that's about, right? And the capitalization has to do with our conversations with Auto Capital and other large-scale investors, which are ongoing right now. And in fact, Ed and Navneet and I meet with David Otto tomorrow to take those negotiations towards their completion.
Now the acceptance of ETH and Bitcoin. Okay, that why wouldn't you start that right now? I guess because of price.
No. The reason is straightforward. It's because we want to be able to give our coin a lead.
Well, I'm saying you can still allow them to be converted.
Oh, I see. So we allow Ether and Bitcoin to be converted to our coin, with those holders understanding that there is a lead for the coins coming from AMPS.
Right. That way we can, they can get started without early.
I see.
Essentially an ICO, right?
Right, and it would be, and people would probably invest.
I see. I understand what you're saying. Okay, that makes a lot of sense, and that provides a kind of legal structure. That provides a legal structure or framework within which we can conduct this without. Oh, okay, I'm slow on the uptake.
I must be really slow. So how is that different than an ICO?
Well, first, maybe it is an ICO.
The intent is different.
I see.
The intent, yeah, the intent is completely different, right? We're not raising funds to capitalize, right? What we're saying is that this is really a part of a redemption process, right?
Part of the story might go, if you've already cashed out of AMPS and now you have Bitcoin, there's still a path for you.
That's exactly right. Okay, very, very good. I'm now happy with that solution. Very, very good. All right, so that means we have to amend the terms and conditions. So, and HJ provides the most important question of all. Thank you, HJ. And I would say it would have to be equal to the AMP value. That's probably the most reasonable solution.
Yeah, at like the start of the redemption process or something.
Yeah, that's correct. That's exactly right. Good. This is great. I feel like all of these have super, super positive stuff going on.
In regards to like non-technical proposals, when would be an opportune time to submit those? Example being like marketing proposals, community development, things of that nature.
That is such a great question. Who wants to like be the person to collect those and begin the process of evaluation?
I could be one of the persons. I don't necessarily want to be the person.
Awesome. No, that's good. I get it. How about you? Use Slack as the coordination mechanism and get a group of people together to collect and begin to curate proposals like that, and then we set up a community process that we're all happy with.
Yeah, that's awesome. Some of the early things that are needed are, a brush up of the landing homepage and deciding on an icon and securing some channels for RChain co-op, Twitter, Facebook, whatever, a bunch of things.
Yeah, absolutely. And so here's a thing that we really need, which is for everyone who's feeling bullish and positive about the conversion, which I would like to happen before Christmas, if at all possible. I don't know if it's possible, but certainly before the New Year's, to get the word out about the conversion process. So let's figure out the best way to get the word out to all those who are interested, all those who might want to know that this conversion process is happening, and so that everyone has the opportunity to participate. So I think that's probably the most important thing, is getting the word out about the conversion, the redemption process. With that, we're.
Okay, yeah, so just to clarify, because you cut out real quick, coordinate outreach for the conversion event and then curate proposals on the Slack?
Yes, indeed. And
Okay,
Christian, I do have a simple logo proposal there that sparked a bunch of ideas. So we're going to need to coordinate a curation, review, and selection process. So let's set that up as ASAP. It might be fun to do on New Year's Eve, right? Is the the RChain logo selection process. For those of you who have nothing better to do on New Year's Eve.
Yeah, and I just want to remind everyone in the community, if they have ideas for proposals, they can put them up at rchain.consider.it.
Okay.
And select a team of interested people.
Very, very good. Thank you, Jim. Okay, guys, I really have to jump off. I've got a bunch of other things to do, but looking forward to talking to you next week and keeping everyone up to date. And let's stay in touch on Slack. And again, many thanks to you, Christian.
Yeah, no problem.
All right, so.